Our goal in this video is to configure a WEG CFW320 Series 3 horsepower VFD to control a 24,000 RPM, 2.2 kilowatt CNC spindle locally from the drive's keypad. We'll also add a switch so we can tell the drive to accept commands remotely from a CNC. While this video uses a WEG CFW320 Series drive, the WEG product line is very consistent, so these instructions will work the same on other WEG series too. Now before we get started, why use a WEG CFW320 Series VFD? Well, it's a full-featured industrial drive, of course, but what makes it really stand out to me is the incredibly small footprint. These are all 3 horsepower drives. Yeah, crazy, right? Also, the WEG drives can be zero stacked. You can place them side by side and only need about an inch of airflow above and below. So these drives really shine when you have limited space. They also have a built-in PLC, free configuration software, free PLC programming software, and Automation Direct ships them next day via free 2-day shipping in the US, have a 1-year warranty, a 45-day no questions asked return policy, and free customer support based right here in the US. And they come with enough I/O that will cover 99% of most applications. But if you need more, they have numerous option modules for both communications and I/O expansion, so you don't end up paying for I/O you aren't using. The CFW320 is the next generation, bigger, better, faster, stronger version of the original CFW300. Now the 300 is still a good solid drive, so if you have an opportunity to pick one up, grab it. This is everything we'll be doing in this video. So if that's all you need, stop the video, grab a screenshot, and go do it. If you want to understand why we chose all those values and pick up some hints and tricks along the way, well, stick around. We're going to walk through this in the order shown. There are timestamps to each of these steps in the description below if you just need to learn more about a specific topic. I'm using single-phase 220 to power this thing, and I wired it like this. Those terminals are on top of the drive. The spindle wires come out of the bottom of the drive, but don't wire the spindle yet because step 1 is always to recondition or reform the capacitors without a motor connected. Why do we recondition the caps? Because the dielectric oxide inside them slowly degrades when there's no voltage applied, and that increases the leakage current. So if you hit the capacitor with a large current surge, the innards get hot and damage or even explode the capacitor, and now you have an expensive paperweight. Reforming the WEG capacitors is easy. The label on the drive tells you when it was manufactured. The manual says if the drive's been unpowered for more than a year, to apply line voltage to the VFD with no motor attached for an hour. Then let it sit for 24 hours unpowered. That's it. That will recharge the capacitors and help ensure you get a good long life out of your VFD. So don't skip that step. While the drive's still powered down, go ahead and wire the drive to the spindle. Just remove the front cover and connect these guys to the spindle terminals as shown here. Now if the motor spins backwards when you start it up, simply power everything down, swap any 2 of these wires, power it back up, and it should be running in the correct direction now. Now make sure you use a flexible cable specifically designed for VFDs or servos, and that the cable shield is grounded to the chassis on both ends. Now that's the opposite of data cables where you only want to ground one end. Why is that? Because in power cables, you're trying to prevent noise from getting out. In signaling cables, you're trying to prevent noise from getting in. If the shield on the data cable is grounded at both ends, then external magnetic noise can induce currents in the shield, which can mess with your data. Removing the ground from one end breaks that circuit. Grounding the power cable at both ends, the currents in the shield generated by the magnetic fields inside the cable get routed to ground to minimize how much EMI gets out. Exactly what we want. Okay, let's configure the drive. I'm going to go to parameter 204 and enter a 5 to reset the drive to the 60 Hz defaults. If you're using 50 Hz, then you would set it to a 6. The WEG drives assume you're using a standard industrial 50 or 60 Hz motor and that you bought the drive with a power rating that matches your motor. Given that, they preset everything for you, which means the drive normally works right out of the box. You just wire it up and go. But we don't have a 50 or 60 Hz motor. We have a 400 Hz motor. So we have to go to parameter 202 and tell it to switch from volts Hertz mode to vector mode. VVW is voltage vector WEG style. We do that by entering a 5. Now the good news is we now have a vector drive instead of a standard run-of-the-mill volts Hertz drive. And this is a much higher performance mode because instead of the drive guessing what the motor is going to do, we'll tune the drive for our specific motor. This is a big advantage of the WEG drives, and it's quick and easy. Parameter 400 is the motor rated voltage. Ours is 220 VAC, which is the default. Done. P to exit. Parameter 401 is the motor rated amps. This one is 8 amps, so we enter that and accept it. Parameter 402 is the motor rated speed in RPM. Ours is 24,000, so we scroll to that. This is going to take a while, so I'll fast forward the video. I do wish WEG had a way to jump around instead of scrolling the entire number range. Okay, accept that. Parameter 403 is the motor rated frequency in Hertz. Ours is 400 Hertz, so we scroll to that and accept. This frequency is what controls the motor speed. Parameter 402 is the RPM version of that, which gives us our scaling factor. Parameter 404 is the motor's rated power. Ours is 3 horsepower. The manual says 3 horsepower is an 8, so we enter that and accept it. Now that we've told the drive about our motor, it needs to measure the stator resistance so it can accurately control the motor. Just set parameter 408 to a 1, and the drive takes care of the rest. The result is in parameter 409 if you're curious. Great! We now have a fully characterized and tuned motor that the drive will be able to control very accurately. Motor control. Parameter 100 is the acceleration. How about 1 second? Hopefully that won't give us an overcurrent fault. I'll show you how to check that in a minute using the bar graph display on the keypad. Parameter 101 is the deceleration. Let's see if we can get away with 1 second on that one too. Again, we can always change it if it creates a problem. Parameter 133 and 134 limit how fast or how slow the drive can go. G-Sender limits us to 7,500 RPM and 24,000 RPM by default, which for our 400 Hz spindle is 125 and 400 Hz. So I'll go to parameter 133 for the min frequency and scroll to 125. Uh-oh, we got a configuration error. What's wrong? One of the great things about the WEG drives is they monitor everything you do and notify you via this configuration error when they see an issue. So you find out before you try to run the drive. How cool is that? Now, whenever you get this configuration error, simply go to parameter 47 where you'll get a code. Then go to this table in the manual where you see that code tells us we tried to set the minimum frequency above the maximum frequency. Yeah, that'd be a problem. So let's go to parameter 134 where we see the max frequency was set for a 60 Hz motor. Our spindle's 400 Hz, so we scroll to that and accept. Now if we go back to parameter 133 and try to scroll to the min frequency we want of 125 Hz, yep, no configuration error. Perfect. I really like that feature of the WEG drives. Okay, let's do a quick test. Scroll back to parameter 2. That's the current spindle speed. Hit run, and yep, the spindle spins up. Bring up the tach, and sure enough, 7,500 RPM. But what is this number in the display? Well, the display is assuming a 60 Hz motor, and we've totally messed with that. So let's fix the display. Parameter 205 selects what's shown on the display when the motor is running. You can put any parameter value you want here. There are tons of things you can monitor, but we want the default of being able to control and monitor the motor speed, which is a 2. Exit that. Parameter 208 is the max value we want to see on the screen. Scroll to 2400 and accept that. And then parameter 210 sets the decimal point. We'll put that at 2 decimal places so the display reads in thousands of RPM. Parameter 209 is which units to display on the LCD. We want RPM, so we enter a 7. Parameter 207 is the parameter shown on the display bar graph. It defaults to a 3, which is the motor current. It's a great visual, and we'll use it in a few minutes. Go back to parameter 2 to view the motor speed, which is what the drive will default to on power up, and hit run. And there it is, 7,500 RPM. Perfect. Bring up the tach to verify. Yep, exactly what we expect. Change it to something else. I'll fast forward the video, it's going to take a while. And check that. Yep, perfect. Hit stop. Let's check one more thing. If you set the acceleration too aggressively, the motor can demand more current than the drive can provide, and you get an overcurrent fault. We set our acceleration to 1 second. How we doing? Remember, we set the bar graph to monitor the current. So watch it while I hit run. That barely moved the bar graph, but it was at 7,500 RPM. Stop that. And let's scroll all the way to the max of 24,000 RPM. I'll fast forward the video. Hit start. Looks like it only hit 4 bars. Easy. Let's go back to parameter 100 and change the acceleration to the smallest possible value, 0.1 seconds. Now that takes effect immediately, so we just hit run, and yep, we got a lot more current, but we didn't fault out. Now I'm going to put the acceleration back at 1 second because it's more than enough for CNC style jobs and it doesn't stress the system nearly as much. You can pick whatever you want, but how cool is it that we can quickly evaluate and adjust how the system's doing by watching the bar graph? That's one of my favorite features of the WEG drives. By the way, you can scale the bar graph display to anything you want using parameter 213. By default, it scales to the drive max current rating, which for this drive is 11 amps. The drive's rated amps is shown in parameter 295 if you need to look it up. The drive is pre-configured out of the box for local control of the motor via the keypad, which is why everything's been working so far. Let's add a switch to tell the drive when we want it to be controlled by the remote CNC. We'll use digital input 3 for that because inputs 1 and 2 default to stuff that we'll want to use in the PWM control video. The terminals on the drive are numbered like this, and the digital inputs are pulled high, so I'll just add a switch between these two terminals to ground pin 3 to switch to remote mode. There's a link to the switch I used in the description below. If we go to parameter 12, we can see the digital inputs. Flip the switch on, and yep, bit 3 is active and gives us a 4, exactly what we expect because each bit adds its position in a digital word to this number. Well, great. We now know the switch is wired correctly. Okay, now we have to tell the drive what digital input 3 will be used for. Parameter 220 tells the drive what will control the switching between local and remote modes. We could tell it to always assume local, always assume remote, use serial commands to select it, Ethernet, or even the built-in PLC. I like having the ability to switch between the two, but if you don't want to add a switch, just tell it to always use remote CNC. Then if you need local control, you can just switch this parameter to a 0. It's easy and no need for a switch. Your choice. I like having a mechanical switch, so I'm going to set this to a 4, which tells the drive we'll be using one of the digital inputs to switch between the local keypad and the remote CNC for drive control. Now, which digital input? Parameter 265 defines digital input 3, and we want that to be used for local remote control, so we enter a 9. The local control defaults to the keypad, which is what we want, so we're done. If you need to check that or want to change any of those, these are the parameters you set to tell the drive where the frequency control, forward and reverse, and run stop control comes from when in local mode. Again, it defaults to the keyboard, so we don't need to do anything here. Well, let's try it. With the switch in local mode, we can press run and the drive spins up to speed. Stop. Switch to remote mode, and now we can't control the drive from the keypad. It's looking for commands from a remote device. Switch back to the local keypad, and yep, now we can control the drive from the local keypad. Perfect. Now we need to decide which remote method we want to use. There are lots of ways you can control the frequency input, but we only care about RS485 or PWM, so we'll set that up in those videos. Now I would suggest watching both of those videos to see what's involved, That way you can pick the one that's best for you. In a nutshell, RS485 is the most robust and accurate, but the WEG CFW320 series drives don't have any built-in comms, so you have to purchase an RS485 expansion module. PWM control isn't as robust or accurate, but it's the quickest and easiest way to get running because the remote mode is already configured for it by default. But you'll need to purchase an inexpensive PWM to voltage converter board because the WEG CFW320 doesn't use PWM as an input for frequency control, but it does have an analog input option. It's your choice. Again, watch both videos and see which works best for you. By the way, if you want to learn more about the WEG VFDs, Automation Direct has a ton of tutorial videos walking you through various features of these amazing drives. I put links to those, the CFW320 Drive, manuals, all the parts I used, and more in the description below the video. One final note. While we told the drive to decelerate over 1 second, did you notice it didn't do that? Let's get it spinning and watch what happens when I hit stop. It took longer than 1 second, and you can hear a pulsing sound as it decelerates. You can learn all about braking in the CFW320 series drives in this video, and also see a quick and easy way to get braking times of less than a second.